That's nice. Okay, guys, so welcome everyone. Today we'll be coding a fun, simple Python script to generate excuses. If you're somewhere that sometimes you're running late, or you woke up late, or you just have your mind somewhere else, this coding solution will help your life. You'll see that technically speaking, it is a very simple thing. Like it consists in almost 20 lines of Python code. So you will see that you'll get the hint out of it super quick. But as I was saying at the beginning of the workshop, if you were not here, then I will repeat. Um, the interesting part about this workshop, what I believe is interesting, is that I will basically guide you through a deep dive on Python. Of course, not super deep dive because that's a whole area of study, but we will have some time to understand what's happening behind the scenes aside from just running a script, right? We will understand what's going on there, right? We will be adding things to our script so it becomes more professional, so it becomes more bold, more stable and scalable. And lastly, we will see how everything operates step by step thanks to a tool called the debugger. All right. So I want to add that this workshop was a little bit of a challenge for me because past workshop, this is my third one. Past workshops, I used to explain things that were a little bit more technical complex. So workshops tend to last like 1 hour and a half, maybe 2 hours, but I think that will be the longest one. Today workshop is not super long, it's like 1 hour. And the main challenge was like, again, the solution is 20 lines, super simple, right? So my challenge was like, how can I make this lengthy so I don't get you guys bored, but I also provide you with important stuff. So I thought of myself like, okay, let's try to give the attendees a more like of understanding what's going on with Python. All right. So this workshop is for coders and no coders. So if you have no background in programming, that's okay. This is going to be recorded. In fact, it's being recorded right now. So you will have it on YouTube. You can follow up if you want. If you want to open your coding to your editor, if you want to code along, that's perfectly fine. But if you want just to lay back and hear me talking and see me do stuff, that's also fine. All right. So without further ado, let's do it. So let me share my screen. I got a slides that I want to share with you. So I'm sharing my screen. Oh, yes, here, right now. All right. So first things first, I'll share with you this link so you guys can have access to it, so you guys can read it. Like, don't get lost in it. Just save the link somewhere else. If you want to follow along again, that's nice. But if you want just to save it and then take a look later, that's also perfect. All right. So the title for this workshop, it's Let's Build an Excuse Generator with Python. All right. It is provided by 4Geeks. I am your instructor, Camilo Villegas. I didn't present myself, but I'm a full stack developer. I've been doing this for 4 years or a little bit more. I started building video games back in college, but then I went a little bit more corporate, a little bit more product oriented. So I went to study on my own. I was also in a boot camp back in the day, and then I started doing full stack development. This year, I set a goal for myself. I said I want to become a teacher, and I found 4Geeks. I enrolled at 4Geeks, and I'm very proud to say that I had a cohort, Miami 52. Woohoo! I don't see anyone from the cohort here, but that's fine. But I was a teacher at 4Geeks. I will be the teacher in the cohort of November, I think, and I'm really, really proud of what we accomplished. And I believe that 4Geeks is giving you the right material to really, really get a job, really land it. I think that this is an awesome community. And I'm doing these workshops every single month, like once a month. So if you like what you hear and see, then stay tuned. All right. So let's continue. First, some considerations before we start. There is a lot to cover, so we'll go a little bit fast, right? Again, this is recorded. Don't get confused. I mean, don't get frustrated. That's fine. If you're not going to talk, mute your mic, please. If you're doing something in the background, turn off your camera too. If you want to say something, if you have a question, you can use the icon here in Google Meet. So it's like a little hand to ask for a turn to talk, just as I did right now. Then I will give you the word, and then you can share with everyone your question. Use the chat wisely, please. If you're going to write something there, let's make sure that it's worth it, that is valuable. Sign colored on underlined text is clickable links. So if you click here, you see that this is a link to 4Geeks homepage. So if you're following up with the slides, you will see that in many places we got links and links. All right. Last but not least, be nice, ask questions, have fun. I think that's fundamental. Now, what's the agenda for today? First, we're going to talk about what's GitHub. Then we're going to talk about what's Python and why is it important. And then we'll talk about what's the CLI. All right. So that's the first stuff. So we're laying the foundations of what we're going to do today, just some explanation what's going on. Then we will go straight to developing the solution. You will see that it's a very straightforward thing. And then I will teach you guys, I will guide you through how Python works under the hood, right? Today we will learn more than just running a script, okay? So we'll learn how Python handles what you wrote, what's going on, why does it show me a result in the screen, right? And what's going on behind the scenes, behind the hood of all of those processes. We will understand what's going on there. Then we will jump into good practices. This means that our first solution, we will tweak it. We'll make it better, all right? And we will make it better thanks to good practices. Now, if you're working in tech or you wish to work in tech, there's something called the good practices or standards or coding rules, whatever you want to call it. But they are just some things that you gotta take care of, like the naming of variables, like the order of the code that you write, like some technical stuff, like concern of responsibilities, things like that. Those are good practices. And when you are applying to a job, good practices will speak for you. If you are able to really have a code that has good practices, good standards, people will notice that. And they will say, okay, this guy knows how to code. So I will teach you some of those good practices that are important, that will make your code look pretty, and that will make it more understandable. All right? So once we're done with those tweaks, with those changes into good practices, then we will see how everything behaves the same, but it's now more robust. All right. And we will take a look at it with the debugger. All right. Why? Because the good practices add a little bit more of syntax and maybe you guys can get lost, but you will see that with debugger, it's actually doing the same. The debugger is just a tool that runs your script step by step, right? Not just like immediate. No, it will go step by step, showing you what's going on. All right. And this is an awesome tool because once you're working in tech, you will see that sometimes you don't know what's going on. Like, okay, this is working, but why? Or I don't know why is this result coming? Where is this result coming from? When you use a debugger, you see how the code evolves every single line of code. So that way you'll understand first what's going on, and second, you can catch bugs that way because you can know where is the error happening. And I will teach you that too. So let's continue. Let's start with GitHub. Oh, but before we start, I want to ask you, do you have any questions? Do you like what you see, guys? You can throw me some emojis. You can talk.
I'm totally new to programming, and I was just curious what programmers typically use GitHub for. Is it almost like a Reddit for coders where they can like exchange information or tips?
Well, you talk about GitHub.
Yes, it looked like you had mentioned GitHub earlier.
Yeah. All right. So that's why we got this slide right here, that I like to explain things first. I like to give context, and then I like to like tone it down a little bit, like to give real life tools that you're probably more familiar with to kind of like associate the utility of it. So I think you got it straight, Clara. Um, GitHub is like Reddit for programmers, or better, it's like a Google Drive. All right. So once you're coding, you have like the necessity to store your code somewhere, right? And even better, not just store your code, but also work alongside people. Like I do my stuff and then I will send it to you and then you will add your stuff too, right? So we need a single place where all of that takes place. Now that's GitHub, right? So let's read here. GitHub is a platform for hosting code. That's what it is. And it's manipulated with Git, all right? So we won't go to Git. We won't write any single line of Git today. But if you're interested on dealing with control versions, with learning more about GitHub, then you should go with Git. Now, Git is the bread and butter of your everyday programming experience. Git is very important because this is the tool that we use to collaborate with people, right? Whoever, I mean, the let's put an example. Uber, the application. Now, Uber is built by a group of engineers, not just by one person. And the way they share code and ideas is thanks to Git, right? So, a series of commands to upload, update, and delete the hosted code. So that's Git. Git is a set of commands that you can use in your computer so you can manipulate code, right? But GitHub is the platform. That can be a little bit confusing, but I will let you search that. That GitHub and Git are different things, but they work together, all right? So GitHub is like Google Drive for programming projects. This is the bottom line here, right? You want a place where you want to search things, sorry, where you want to store your code, then that's GitHub. This is where you store your code. We will see later in the workshop an actual example of this. Where is code hosted on GitHub? We will see that. Now for this project, we must have a GitHub account. You can create one here. So this is, oh, of course, it won't show me the sign up page because I'm already logged in. But if I get this with incognito, I think I can show you guys what actually looks like. Yeah. So here you can sign up. You can create an account. If you already have an account, that's perfect. If you don't have an account yet, I will tell you, you can do this step later, right? I want your attention here. So yeah, once your GitHub account is created or you already have one, open the project. Let's build an excuse generator with Python. So let's do that. Let's open this link, and this link will take us to this 4Geeks page. So 4Geeks is not only the academy, it's also thinking of like a dashboard with projects and exercises. You can find 4Geeks documentation free because they believe in like teaching and learning should be free and open source. All of their code and teaching material is hosted on GitHub, so you can search it. And this is an actual project from what we teach in 4Geeks. All right. So here it's like the description of the project, and then what's the goal, what are the instructions, discuss with your clientmates what's the strategy first, how to start the projects. In summary, this is just like a description and how to start the project on this excuse generator CLI. All right. Today, I'll follow the steps to actually code this project right here. So you don't have to really read all of that because I'll be doing it here live. So yeah, that's that. So now we have our web page with excuse generator. Now, oh, let's continue with the slides. So now we know GitHub. That's beautiful. Oh, in fact, let's click it here. If we read here repositories, is click to open. Now repository is like a folder, all right? It's the folder where the code is stored. So here it's like 4Geeks is giving us a template. And then we will be doing a copy of the template and working on it, right? So we're not actually modifying the current 4Geeks code. No, we are making a copy and working over it. Is that understood, guys? Let me know. Yes? Yes, go ahead.
Sorry, I pressed the wrong button. Thumbs up. My bad.
Okay, beautiful. All right, so this is GitHub Clara, and this is GitHub everyone. Let me present it to you. We see that we got files. Like if I open this file right here, called readme.md, we see that it stores things, right? Of course, it's not super easy to understand at first glance. It's different than Google Drive, but at the end of the day, it's doing the same thing. It's storing files, and each file has some information. That's it. If I go here, we can see actual code written on it. We're just storing files here, right? So 4Geeks is providing us this template, and from this template is where we're going to code our solution. So let's continue here. So that's GitHub. Now we know what's that. Now what's Python? This is the important stuff, guys. So Python, I like this one. It's a high-level interpreted programming language, and its main features are syntax clarity, dynamic typing, and extensibility. All right, so I know that this might sound like Chinese to some of you, but what I want to say here is that Python is very cool and it's very flexible, and you should learn it. This is what I advise you guys. And it's not because Camilo Villegas is saying it; it's because statistics from the world are saying that. All right. So let me open this link right here that says check Stack Overflow developer survey. So let's open this. And let me ask you guys, how many of you are familiar with Stack Overflow? All right, Damien, no, Raul, okay. Some of you are, some of you are not, but that's fine. So Stack Overflow, yeah, Clara, you want to say something?
No, that was a mistake.
Okay, fine. So Stack Overflow is like your best friend. Now, Stack Overflow is the place where programmers ask questions and answer questions. So if you're doing something, if you're coding something and you're stuck, then your place to go is Stack Overflow. You ask in Stack Overflow. You search on Google, like, how can I do this? Press enter. First entry is Stack Overflow. In fact, let's do something like, how can I sort an array in Python? That's a question. Look at this. First thing, Stack Overflow. How to sort an array in Python. Same thing that I wrote. Now, when I go here, it's basically a question and then an answer. So this is programmer's best friend, because coding is difficult and sometimes you have questions. Stack Overflow is the place to really solve those. So yeah, yeah, that's true. Without even realizing, Stack Overflow is super nice. So why am I showing you this, guys? Now, this is a survey that Stack Overflows as an organization runs every single year. And the amount of people that answer this survey is of the number of hundreds of thousands. It's a lot of people, all right? A lot of people. So it's a very nice source of truth to see what's going on with the technology landscape. All right, so what's this? If we check this, programming, scripting, and markup languages, we see that Python has like a very good response rate of 48% of what people like. Now, this was done in 2022. We'll have another response in 2023 at the end of the year, but this is what people marked as most popular technologies. Now, you see that Python is on the top list. All right, this is all respondents, of course. Now, if we go down, let's see, work that I know that a lot of people is interested in this one. Employment, let's see if we can search for something, salary, purchasing technology, hold on, work technology. Okay, top paying technologies, look at this. Platforms with frameworks, okay. So we see that on top, we see programming languages and tools that are a little bit obscure. Well, not obscure, but few developers really learn them because there's not a lot of jobs on them, but because developers on, let's say, Clojure are so rare, they earn a lot of money. But that doesn't mean that that the message is go learn Clojure. No, trust me, you don't want to learn Clojure at first. You want to do something like Python that is right here. All right. So this actual statistic is showing you guys that there are many programming languages, but Python is well set. All right. If you check it, Python is earning more than TypeScript or than C Sharp or than C++ or than JavaScript or even Java, that are programming languages that have been running for 20, 30, even 40 or 50 years. All right. It sits on top of all of them. It's easy to learn and it's top paying. So, guys, if this doesn't convince you, I don't know what will. Probably a more tech part is that this is Python is super extensible. That means that you can use Python in a lot of stuff like web development, desktop applications, software development, education, database access, a lot of stuff. And the reason why is because of the community, right? So Python has been a language that is not only easy to learn, but also that people really love and really love to create things with this language. So you have a lot of tools in your disposal. Now, last, so we can start actually coding, is what's the CLI? Now, if we check the title, if we check the actual title here, it says the excuse generator CLI. All right. So what's the CLI? Let's read this here. CLI, or Command Line Interpreter, is a text-based interface used to interact with computer operating systems and software by typing commands into a terminal and then being interpreted by a shell to generate some output. Now, this is probably the most technical part of the whole workshop, but what I want you to really get here is that the CLI is just this. It's your terminal. It's the screen in your computer. It's where you will see the output. That's the CLI. It's very simple. Of course, behind the scenes, it's a little bit more technical, but in the superficial way, it's just this. Look, when we run the Python script, you see that we get a result. This is the CLI, what you're seeing right here. All right. So we can learn a lot of the CLI, but today the only thing that I want you to understand is this, that this is the CLI. This is where we are going to run our script, our Python script. All right. Some of you that might be a little bit more technical advanced will ask, oh, Camilo, what is the difference between the shell? Oh, yes, Janet.
Raul left a message.
Okay, can you be a developer by knowing just Python, or you expect to know other languages minimum to get a programming job? That's an excellent question, Raul. Thanks for asking. So it depends. It is like it's a mix of things. And when I say this, it's a part of what do you like to do, like what do you like to learn. If you like Python, I think that you should learn Python, right? And the other part, I will say like 70-30. So 70% is about what you like, and 30% is about what is the industry asking for, right? So there are times where the tech industry is asking for a lot of Python developers or Java developers or I don't know, PHP developers, right? So that is important because sometimes you learn a tool, you learn a programming language, but there are no offers available, right? So you also gotta like kind of balance that. But of course, the most important part is that you like it, that you really understand what's going on with Python. So for a job, uh, they will most of the times they will require you to know your stuff, right? So that means to know Python and to know the tools that work alongside Python. All right. Now, for more like generalistic positions or for more advanced developers, it's not like the company expects you to know more languages. I mean, languages are a tool at the end of the day. What I want to say is that a company can require you to learn more languages. All right. But most of the time, they will just require you to be very good at what you do with your uh, with your main programming language. But sometimes a requirement from a company can come and can say, like, okay, we want to do this in a different language. And now they will ask you, are you up for the task? Do you want to learn this? Right? So now that will be your decision, because you can say, no, I want to be a Python developer. I want to live and die as a Python developer. That's cool. But of course, try to think about it, because then you will be losing a lot of opportunities. Right? Does that answer your question, Raul?
Yes, thank you.
Sure. Sure, my pleasure. All right, so let's go here again to the CLI. So the CLI is just what you see here. It's the terminal. All right. Now for the more technical advanced that you ask, oh, what's the difference between the terminal, bash, shell, a lot of stuff. That's a little bit of a discussion. But what I will say is the CLI is the mix of the terminal and the shell. Let's leave it as that. All right. So we got the most important stuff: GitHub, Python, CLI. So before we start to actually code, I want to ask you guys, is this clear? Do you have any questions? Okay, all good then. So let's get to work. Let's start. So I already opened the repo that you see here. If I go with here, you will see that it redirects us to the same place. So here, once I have my GitHub account, the next thing that I will do is that one very cool thing that GitHub provides to us, it's something called code spaces. So a code space is basically like a cloud machine. And I know that sounds scary, but basically what it means is that you don't have to set up anything. You don't have to download anything. You can code your solution online. That's the cool stuff about GitHub. So now that I have my account, I go here and code, and then you will see that says code spaces. So here I can create a new code space, and that's what I will do right now. Create a code space on master. So I click here, and then it will open a new tab. And what I will do is that I will set up like a virtual computer in the cloud, online, just for us, just for me, right? And what is that computer going to have? This stuff right here. It is like activating a computer to actually solve this exercise right here, this project. So now it is done. We see that we got the exact same amount of files here on the left. You can see that I can navigate them. That's fine. Okay, I see that this is in Spanish. Let me change it super quick. Okay, it's restarting. That's fine. Perfect. All right, so the first thing that I will ask all of you guys, if you're following along with the code spaces, is that we got to install the Python here. Do you want to install the Python extension from Microsoft for the Python language? Let's do it on install. All right, so what this means is that you have Python right now working. If I run a script of Python, it will work. But the thing is that the idea behind this stuff that we're seeing here, that this is a code editor, that means it's a tool to write code. The idea behind the code editors is to make our lives easier. How does code editors make our life easier? They highlight stuff. They autocomplete. They show us hints when we're coding. All right. So we won't have that if we don't install this. So of course we want to install it. You will see that it's a very simple thing. We click on install. It says installing, and in a couple seconds it will just finish. Let's wait a little bit more. There you go. So now it's installed. All right. So what this means is that when I do, let's say, a random dot, oh, and I think it's not. Okay, perfect. Now it's asking us to install more extensions of Python. Again, this is not mandatory, but I will really suggest you to do this because it will aid your developer experience. So let's go back here. And if I now see, I got these red squiggly lines, these yellow squiggly lines that we didn't have before. Now the editor is basically grabbing the code of Python and is giving you hints. It's helping. Here is basically telling me like math is not accessed. Unused import of math. This means, hey, you are importing something, but you're not using it. So why are you importing it, right? So if I do random dot, you will see that I have an option of things here. So I don't have to code straight from memory. So this is the power of code editors. They give us hints on how to code better, all right? So that's why I installed this. Sorry, this is why I installed this Python thing. If I uninstall it, you will see that this won't happen anymore, all right? Okay, that's fine. So now we have everything. And taking a quick look on what we have here is that we have a single import. Let me do clear here. Okay, let me whoop and give more space here. Perfect. All right, so for the files that we have on the left, we got a README that is basically like the instructions on what to do. We got the README in Spanish, same things. We got the GIF that we saw later, like what should be the result. We got this learn.json. Please ignore this file. We don't have any use for this one. And then we got the app.py, that this is the actual file that we really need our eyes into. All right. So this is the file where we're going to write Python code. And later on, we will execute this file so something happens. Okay. Now, the first line of this, yes? Oh, yeah. Any questions, guys, before we continue? Okay. I think everything is fine. Okay. So first line, it says import random. All right. Larger text. All right. What about this? Good? Better? Perfect. Beautiful. All right. So it starts with an import random. So basically what it's doing here is that Python is a programming language that has something called modules. Modules are like pre-built tools, all right? When we are, let's say we are, let me move this here. Let's say that I want to create a new thing here. And I write, hello 4Geeks, right? So this here, this bold stuff it's like a little module. No, think it this way. This bold, italic, underline stuff is like a module to edit the appearance of this text right here, right? So it's a pre-built functionalities. You don't have to do anything weird on this Google Docs. You just click here and then something happens, right? It's pre-built. So for Python, it's the same thing, right? Why? Python developers know that sometimes you need to do random things. You want to generate random numbers, you want to generate random choices, you want to generate random stuff, right? So they know this and they build a module full of random utilities. So when I do random dot, you see that we have choices, Gauss, get state, run bytes, run int, run range, sample, seed, shuffle, a lot of stuff. They're giving us logic that we don't have to really think about that. It's already done, right? So that's that. So when I import this one, I'm basically saying I want to access all of those pre-built functionalities. And the way I access them is that I write the name of the module that is random, and then I do dot, and then I can choose one of the pre-built functionalities. All right. So let's remove this and let's read the README. So we know what we want is that when I run the script, it generates an excuse. Let's read this one. My dog ate my homework yesterday. All right. So the way this is like planted or based is that we need this, right? We need to create some variables. So variables are like we are storing some data. Okay. We see that the actual like a structure of an excuse consists on three things: a who, a what, and a when. All right. So if we check that here, we can make a lot of combinations. Like my grandma crushed before the class, or my bird broke when I finished, or during my lunch, right? So what we want is that we want to get one of these words, phrases, one of these words and one of these phrases, and then mix them together, like join them, get them together so they can make up SKUs. Here we can see the example again. My dog ate my homework yesterday, right? It's who to blame, what they did, what do you want to avoid, and then the last thing is when. All right. So the strategy that we want to follow is that first we want this to be created. We want like our input, that is our data. Like we want the who, we want the what, we want the when. We want to create that first, and then make the actual logic to pick one of those and then build an excuse. Okay. So let's grab all of this. In fact, you don't have to code this. You just grab it, you copy, and then you go here to the code and you paste it, right? So let's see what happened here. Oh. So your code here, nice. So let's put a commentary. A commentary is it's a line of code that won't run, that won't have any effect in your actual logic. It's just something that you want to write, so it gives you a better hint to what's happening there. So the first thing is that declare, or better, create variables with data, right? So who, we got this, the dog, my grandma, his turtle, my bird. What, eat, piss, crush, broke. When, blah, blah, blah. Right? So for some of you, this syntaxis of brackets is familiar, but whoever is not familiar with this, just like try to imagine that doesn't exist. Just like this, right? So who is actually one of these words right here. So if you're curious about what is this brackets notation here, you can read about arrays. So an array is a list. It's a collection of data, right? You can think like a supermarket list, right? We can, if we I just created one, yeah. If let's say that I go to a supermarket and then I say grocery shopping list for today, and then I say that I have to buy X, I have to buy milk, that I have to buy cereal, right? So that's human readable language. If I want to make this Python, then I can do like grocery, and then I do this. I do the brackets, and then I do X, and then I do milk, and then I do cereal, right? So it's the same thing. So imagine you have a list with items. That's an array. And you see that array holds strings. So what is a string? It's just a word. It's a set of characters. It's a word. Right now I'm storing X, milk, and cereal. It's the same thing as if you take like a little notebook and you write X, milk, and cereal. It's the same stuff. That's a physical list, and this is like a virtual list, an array. That's the way it's called. All right. So let's go back here to the actual code. Okay, so we have a list of who, a list of what, and a list of when. All right, so that's fine. Now we want to pick one of this. All right. So one way you can do this, let's create a variable called who excuse is equals. That means that I'm assigning a value to one of the picks here. All right. So I will write something that might be a little bit like weird, but I will explain it down the road. So we can access an item in a list with the bracket notations and then with an index. An index is a number of the positions of the items, right? So what this means is that if I do who at 0, what value do you think is going to get from here? Someone? Don't be shy. The dog. Perfect. And if I do who at index 2, then which one is going to get from this array? He's total. Perfect. Why? Because the dog is 0, my grandma is 1, his turtle is 2, and my bird is 3. Now, this is a very programming stuff, and it's that indexes always start at 0. All right. So again, let's do this example. Grocery at 1. What do you guys think that I will have? Like, what's the value of this thing? Groceries at 1. Someone? Milk. Perfect. Yes, you got it, guys. You got it. So that's that. Now that we understand what's going on with the indexes, then let's add a little bit more of logic here. It's like a ruler. It's start 0. Perfect. I love that. Thank you, Damien, for that. Excellent explanation. So let's do that. Let's do who index, and we will put this here, and who excuse. All right. So what is the who index? The who index will be a random number because we want to have a random value out of this. All right. So we will use this random.randint. All right. So what this means, a randint function, the randint functionality picks a random number out of a range. If I do 0 and 5, if I do this, then this functionality will pick a random number between 0 and 5. It can pick 1 or 0 or 2 or 3 or 4 or 5 or 1, right? But no more than that and no less than 0. If I do randint in the range of 0 and 2, then the values that who index can have can be 0, 1, and 2. All right? Is this understood, guys? Perfect. Now, let's do a quick test here. And let's do 0, 1, 2, 3. So it's actually 3 items. 1, 2, 3, 4. Sorry, 4. 1, 2, 3, 4. Right? So let's do this. Let's do 4. And let's do print who excuse. Right? So what's going to happen here, guys? It's very simple. The first thing that will happen is that this script will first import random module. That means that we will then later we can use the random module. We can use the prebuilt functionalities. Second, we will declare the data, right? Then we will get a random index. That means that we'll get a number of 0, 1, 2, 3, or 4, one of those numbers, and then I will pick a value out of the array, right? So after that, I will print whatever we get from here. All right. So let's see it doing its magic. So when I do Python app.py and I press enter, I get my grandma. All right. So that means that this random operation took which value? What value did it randomly select? Well, not what value, like what number? Think. No, number 1. Why? Because if you see here, we see that the value that it was logged, it was my grandma. And my grandma sits at index 1. So that means that who index had value 1. All right? Let's do something so it can be more understandable. Let's do print who index. So we will print whatever random number between 0 and 4 it generated, and then we will get the actual queues, right? So we got something like this. So let's do Python app. Look at this. So the who index is 3, and if we check on this array, we can see that 0, 1, 2, 3, my bird. All right, let's run it one more time. 0. It got the dog because it's first right here. Now, guys, is this understood on what's going on here? Perfect. All right, so this is basic stuff. Now let's make it more dynamic. And why do I say dynamic? Now, first, it didn't happen, but let's run this until it happens. That we should trigger an error at some point. Let's see if we can make it happen. Oh, come on, you can do it, you can do it. No, it's not happening. It doesn't want to happen. Oh, okay. I'll just force the error. Right. So what happens if I search for a value at index 4? What do you guys think it will happen when I do this? Will it work? It won't work. Why? Because we don't have enough items. If we see we got 0, 1, 2, 3, right? We got no more than that. And I'm searching for the 4th item, and the 4th item doesn't exist. Now, if I run this, you will see that I have an error. It tells list index out of range. Why? Because I'm trying to get the value of something that doesn't exist here. Now, if I create another item, like I am the 4th item, right? And I save and I run it again, then it will work. Because now we have 0, 1, 2, 3, and 4. All right? Let's do it now. If I remove it, then we'll have the error again. All right, is this clear, guys? Oh, yeah, I don't like this silence, guys. Throw me some emojis or something. All right, so what do we have to fix here? All right, if I want to have more excuses in the future, something that will be very annoying is that I will have to change the range here every time I add a value. And we don't want that. We want it to be more flexible. We want it to be more dynamic. So what we can do here is that, of course, every single array starts at 0. That's fine. So we can have it like that. But then the maximum, like the max of the range, should not be a number. It should be like some logic, something that is dynamic. So we can use length. That is a function that gets the length of an array and then -1. Why this? Why this? Now, length of who counts the amount of items on an array. So how many items does this array has? It has 1, 2, 3, 4. So that means that this operation will be 4. And then why do we do the -1? Hey, Camilo, why do we do -1? Because, guys, I want you to understand that index is different than length. All right? Now, who has a length of, has a length of 5. Sorry, 4. It has 4 items. 1, 2, 3, 4, right? But and an index until 3, right? Because the actual index is 0, 1, 2, 3. Now, if this is messing with your head, just think that the index is always 1 less than the length of an array. Just think it as that. Just you always count the amount of items that an array has. In this case, we have 4. So the index should be 3 because it's 1 less. So this way, we ensure that we always have the correct range. We always pick something that is from 0 until the length -1 of the array. All right? Now, let's do that for every single data that we have here. So we got this and this, and now we have to change a little bit. Here, instead of who, we want what. So Changing all of this to what? And then let's do it with when. So I just copied and changed a little bit the code. Now, this is a smart way to work because I'm not writing everything again. I'm just copying and pasting. All right, so when index, perfect. Right, so if we take a look at this, we are doing the same thing 3 times. All right. So for who, we are first getting an index. That means a valid number between 0 and, in this case, 3, right? And we're doing the same for what, and we're doing the same for when. After that, we are storing the value in this variable called who excuse, what excuse, and when excuse. All right. So this might be a little bit confusing. So let's give it a shot here. Let's print. Oh, sorry. Let's print what's the index of this, and then we will see what happens. So for print, we want to print. No. Let's just print the index. I don't know, but we want to print. Okay, yeah, no. Let's also print the actual excuse that is being well, not the excuse, but the word that is actually being fetched there. Let me have this here. Perfect. All right, so let's run it. Boom. All right, so let's make an analysis here. So the first thing that I print is the index of who. That is 0. So that means that the value is the dog, right? Now, let's check this. What index? It turned out to be 3. So if we check on the array, 0, 1, 2, 3, it's broke. That's exactly what we printed here. Now let's take a look here on when index. It took 3. That's the random number 3. So let's see the when. 0, 1, 2, 3 during my lunch. So that's what we printed here. All right. So now we got a working logic. Every time I run the script, we get random indexes, we get random words, and then our last step is to actually merge the dog, merge broke, and merge during the lunch. So the way we do this is with a final variable called excuse. Let's store it there, excuse, and then this will be like a sum. Let me have this here. So it will be plus space plus the next variable that is the what excuse plus another space and then when excuse, just like that. And then at the end, you want to print our merged excuse right there. Okay, so it seems that I'm having an error here. What's going on? Plus, oh yeah, I missed the plus symbol here. All right, so I will explain. I mean, I can explain this, but I think it's better to just show you guys, and you will get it like this. So let's clear our terminal, our CLI, sorry, and let's run it. Done. Look, we just finished, as I said, because I have a lot of prints, but this is the solution to this project. Very simple. If we take a look here, it says my bird pissed before the class. That's the excuse, guys. Weird, but yeah, it works. If I clear this and I run it again, you will see the dog pissed during my lunch, and you see here like the step by step. Like index 0 is the dog, index 1 is pissed, index 3 is during my lunch, and then at the end I merged everything with this. So I'm merging whatever is stored in who excused with the space. Now, if I do a comma like this, you will see that it will affect this result right here. So let's run it again. You see that now it's being separated by a comma. So whatever I write here, it's like the separators between the words. All right. So I'm just doing a space because that's what I want to do, right? I just want a space between the words. So now I have this. So this is the actual solution. This is the solution for this project. As you see, it has mainly like 3 steps. The first one is create the variables with the data. The second is generate a random index and get a random value. And the last step is merge the words to generate the excuse. That's it. It has 3 steps. We define the data, we get the data, right? We generate random indexes to have some random data, and then we merge everything together and then print it. Okay, so guys, do you have any questions here? Please, I want to know about you. Oh, let me connect my computer. It's dying. There you go. Perfect. All right. So this might be a little bit weird for you guys, but that's totally fine. You guys are learning how to do this. We will improve this code, and I think it will become more easier to read and to understand. So that's the solution for the actual project. As I told you guys, super straightforward, super simple. But now we will understand what's going on behind the hood. All right. So first, I want to remove the prints that are not really necessary. That is all of these indexes prints and the values. I don't want that anymore. So I'm removing that. And the only print that I want is the last print. That means that each time I run the script, it will just get the excuse that this is the actual result that we want. Oh, look, what are the odds, right? So I'm just generating random things. Okay, so that's fine. Now, how does Python work under the hood? Now, guys, if you are curious like me, you're probably wondering why when I run this, it's giving me this, right? Like what's really happening behind the scenes. Now, this is what I said to you guys, that I don't want to leave it as superficial, like just run the script. No, I want to teach you what's going on behind the scenes, like really go a little bit more deep. All right. So a lot of people say like, hey, knowing how Python works behind the scenes, that's something very advanced. I don't think that's worth it for people that are learning how to code. For me, that's gibberish. For me, that's not really the best advice, because learning how to learning how a programming language works behind the scenes really helps you to understand what you're doing. All right. Now I will guide you a little bit here. Of course, I won't go super deep. As I said, it can be challenging and very long, but I will just like give you a hint of what's happening when we run the Python script. Right, so let's read this part. It says, all programming languages must be compiled. And the reason for this is because computers only understand binary code. All right. If you ever saw like the Matrix or like those hacker movies where the guys do like write things on the terminal and a lot of zeros and ones appear. All right, so first let me tell you that that's not true. That's not how developers work. But it holds a little bit of true, and it's that computers, machines don't understand this. I know it's like mind blowing, but when I write all of this code, this is not what the computer is reading. What the computer is reading is this. All right, it's this. This is what the computer is getting. So how do we pass from English language, as we have here, to this? The good part is that we don't really have to think about that. Python is doing that for us. And it's doing that for us when we do this, when we do Python, and then we select the file to run, right? So let's go back here. Oh, now this is real for every single programming language. JavaScript also has to be compiled. Java has to be compiled. C has to be compiled. Every single programming language It's just a tool for you to write in the English language. That's it. At the end of the day, what's going on with your code is that it's becoming zeros and ones. The good part is that you don't have to care about that. But we will care a little bit in this workshop. So zeros and one, if you don't know, represent the passage of voltage, electricity into your computer, right? So if it's a zero, that means no energy, no electricity. If it's a one, means electricity. And that's what your computer understands. So look, we just coded in Python, now we're getting into electronics. How cool is that, right? So for Python, that is an interpreted language, we have three main actors. So I won't go super deep on what's an interpreted language, but what you have to understand here is that interpreted languages make your life easier. It's just like they do everything by themselves, right? It's super cool. Now we have three main actors: the source code, the interpreter, and the processor. All right. So I here have something like, let's draw a little bit. So let's open that. This is a Jamboard, and I will write a little bit of things here. So let's grab the actual code. Let's grab all of that. Let's paste it here. Huh? Look at that. Right. So how do we make this? How do we make this the original size? I don't know. I'll just Control C my way. All right. Yeah. All right. So this is the actual source code. This is what we call in the programming world the source code, right? It's the code that you actually write. And how do we convert all of that into zeros and ones, right? What is the process that Python is taking to actually make it like this, right? What's going on? What's happening behind the scenes to make this a reality? All right, so magic, not magic. It's actually very cool stuff called interpretation. So let's write here source code, right? Source code. This is what we have here. This is what we humans write. And in fact, let's write that human readable. I'm sorry, English is not my first language. If you haven't noticed, sometimes I make mistakes. So who needs to know them? No one. No one needs to know that. You can go super close to machine code, something called assembly. We will see in a couple minutes. But no one does assembly really. No one does binary code really. I mean, you do electronics, and electronics is basically binary code, but with hardware, right? Computer readable. You don't have to know binary code. Come on, we're not machines. We're human beings. So source code, binary code, right? Source code is human readable. Binary code is computer readable. Now, how do we go from here to here? Thanks to the interpreter. Now we got the three actors interpreter. Now let's write that here. So the interpreter. So let's do some drawings. Let me tell you that back in college, I used to have illustration classes, so I'm quite of an artist. Oh, no, I'm just kidding. Oh, no. Okay, that's fine here. And you will see why I'm doing these amazing squares right here. This one, let's put a nice blue color. And this one, let's do like a little bit of green. All right, so let's write memory. A lot of people will say, oh, why do I need to understand that? Camilo, stop torturing me. But I will tell you guys that this is, I mean, you won't get this information. Most of places just like omit this part because it's true. You really have to deal with this, but knowing how things work under the hood will give you superpowers. Trust me. So Python virtual machine. And we got here something, the compiler. All right, so the last part is just we paint this like that. All right, so what's going on? The interpreter is just Python and then your file name. That's the interpreter. All right, so the interpreter, let's think the interpreter as a command. All right, so when I do Python and then the name of the file, a lot of processes are going to be triggered. All right, so each time I do this, we get this output, right? But behind the scenes, when I do that, the first thing that is going to happen is that the interpreter will get the source code, exactly what we got here. We will get the source code, and then it will move it to the compiler, right? Oh, sorry. So what's the compiler? The compiler is software that makes your source code bytecode. So what's bytecode? intermediate between human and machine readable. All right. So basically, what we're doing here is that we're getting our human readable thing into a little bit more complex language, right? If I search for bytecode on the internet, you'll see that it's very weird. Bytecode is something like this. This is bytecode, right? So automatically Python gets your source code and converts it into this, all right? So this bytecode, that is like the evolution of our source code, is then sent to the Python virtual machine. So what this means is that once our source code is converted into bytecode, then the virtual machine can read it, right? And the virtual machine basically interprets the bytecode and converts it into binary code and sends it to the processor. All right. So I hit a Python file, right? In fact, it's like this. Sorry, I'm using a trackpad. I'm doing my best. All right, so Python. So when I do Python and then in the name of the file, it gets the source code. It's sent to the compiler. The compiler transforms it into something like this, right? I think I can now paste images. Beautiful. We were missing this from Google Jamboard. Oh man. All right, like this. And then it will generate the binary code. Oh, I wrote it on reverse. Binary code. I like this one. Some people call it machine code. I like binary code instead. All right, so basically what the interpreter is doing is that it is automatically doing two things. It is compiling. That means that is translating your human language into a more understandable language for at this moment for Python. Then Python will grab that and will convert it into binary code. And then when that's done, when this is done, it will send it to the processor, right? So what's the processor? This is our last piece of the whole process. So the processor just gets the binary code, there is instructions, and runs it to give the user an output in the CLI. All right, so let's do normal. Oh, yeah, normal size. No, this one. All right. So basically, guys, the bottom line here is that computers only understand binary code. We're not machines. So what programmers, way smarter than all of us, did is that they created interpreters and compilers. That means that you can write this very simple to understand code, human language, English, and then when we do Python and the command, some processes will take place. And those processes are mainly grabbing this English, well, human readable code and make it a little bit more technical, like a little bit more machine code. Then we'll send it to the processor, the actual processor in your computer, like Intel or AMD or whatever, Razer, whatever you have, and then it will get the binary code and it will tell the computer do this, right? And then when that's done, then we will have this. We will have the result. All right. If you guys don't believe me, let me show you a cool thing here. This is pycompile app.py. So basically here, it didn't remove this. Sorry. So what I'm doing here is that I'm compiling the application, and then we can see that it created a PyCache folder. Now, if I enter that PyCache folder, we see that we got this weird file right here. Now let's see what's inside there. Oh, my computer is lagging a little bit. Sorry for that. PyCache, and then app thing. Look at this. Oh, I want you guys to tell me, who of you understand this stuff? No one, right? No one. This is crazy. Now, this is how binary code looks for the computer. Now, we don't understand this. Oh, wait. You guys are listening to me? I think I'm lagging a lot. Are you guys there?
I'm here.
Oh man, I'm having a lot of lag. I'm going to turn my camera off for a couple of minutes. My computer is dying slowly. I don't know what happened. All right. But is the stream fine? Can you see what I'm doing? Yes? All right, that's fine. So when I run this simple command, what's going on is that I'm basically making it binary code. So no one can understand this, only the computer, and that's totally fine, right? So if I want to see how the actual like bytecode looks like, I can do something like Python disassemble, and then this, and then the app.py. Man, my computer is dying. All right, like this. Look, I don't know who of you are super geeky and technical, but this is something called assembly. Now, assembly is I believe it's like the limit. I mean, it's like the limit of what you can do with human readable languages. Now, people back in the day used to code like this. Now, if you like physics and technology, the first rocket to land into the moon was coded like this in assembly. The programmers back then used this to code because programming languages didn't exist as we know them. They had to do this. These are instructions for the memory and the processor. Very cool, right? Very, very cool. All right. So that's that for knowing how Python works under the hood. Yes, at the beginning of times, it was super cool. And the cool part is that it's still being used. Like as you can see, Python depends on assembly to actually run. That's amazing, no? All right, so that's learning a little bit about how Python works under the hood. Now let's see good practices, because I think, oh my God, I said that this workshop was going to last 1 hour, and we're almost 1 hour and a half. My bad, guys. I tend to talk a lot. So good practices. All right, so the thing is that our code, I know that it's working. We know that it's working, but we can make this better, guys. We can make this way better. All right, so the way we're going to make this better is by doing 3 things. If we go here to the slides, we see that we have three like main strategies here called file split, naming conventions, and modern Python. All right. So what this means is that we're going to turn our code that even though it's working, we want to make it better. All right. We want to make it more easy to read. We want to make it more professional. As I said, take this very seriously, because if you code like this, people will take you more seriously too. They will say, oh, this guy is a pro. This guy knows good practices, right? So let's start. Yes, the Python manifesto. That's true, man. So let's start with file splitting. I put here divide concerns. That means that we should, because right now app.py is doing everything, right? It's doing everything, guys. So let's try to split. Let's try to split those responsibilities. We want that app.py only takes care about generating the excuse, and we need a file to actually like get the data, right? So let's do that. Let's create a new file called excuses.json. Excuses.json, just like this. All right. So excuses.json, if you're not familiar with JSON, it's like a language to store data. That's it. And it has a very simple structure, key value. That's how it works. Key pair, key value, whatever you want to call it. So here, we're going to get these variables that we have here, the who, what, and when. We don't want to create them in the app.py. We want to have them stored in a different file. Why is this cool? Because if someone sends you a file, like a file with a different set of excuses, then you just use that file and that's it, right? So we want to make our code better, more flexible. And hold on. Let's see if I can grab this. Oh man. Yeah. No, my computer is behaving weird. I don't know what's going on. It's like something is stopping it to work correctly. It's like super slow. I think it's because I'm recording the class. So excuse me if if I look laggy, but it's not me. All right, so let's do this quickly. Let's let's do this. Nice. Oh. And last but not least, I'm just doing some pro techniques right here to gain some time. You don't have to do them if you don't want to. All right, but here it's done. That's it. Let's give a little bit of space. A dictionary sequence. Oh man, Jorge, you know what you're talking about. I love it. Yes, we're making like a dictionary here. If you're familiar with Python, we're just doing dictionaries right here. My browser accepts some. There's pending update. A pending update? Oh man, I don't know if that's it. I don't think so. All right, no. Let's just work with what we have right now. All right, so why is this cool? You will see down the road. All right, this is cool because now we can get rid of this. Now we can have an up.py that only concerns on generating the excuse, not the creation of the data, right? So how do we read the excuses.json, right? How do we get the data from there into our code, right? So the way we do this is that we need a special module for that. It's called JSON. All right. So Python also knows that developers like to store their info in JSON files and then read them and then like grab the data that is holding the JSON file and then using it. All right. So let's do that. Here, you don't have to understand what's going on here, but basically, I am telling Python that I want to open a file, right? Which file? You guessed it, excuses.json. So when I do this, .json, and then I want to read That's why I do R. R for read, all right? And as file. So this means that I want to read the information inside excuses.json, all right? So then I will have here like excuses, and then that will be equals to json.load, and then the file. Guys, I know this might look scary, but don't be scared. What am I doing here is that excuses will now be this dictionary right here. I'm consuming, I'm fetching from the JSON file. That's everything I'm doing here. All right. So this is cool because now we can improve our code a lot. Now, if we do excuses, right? Now we need a who, a what, and a when. So let's do that. Who, what, and when. And every single one of them will get the value from the excuses. So when I do this, excuses at what and excuses at when. And then I grab all of this and I will put it inside here. And that's done. So what's going on here? What did we do here? First, a very good practice is that you need to separate stuff based on the responsibility. This means that the excuse.json has the sole responsibility of storing the data, storing the excuses, right? And up.py has the sole responsibility of generating the excuse. That's our first step of good practices. Now, if I run this code, you will see that it works exactly the same. Oh no, I wrote this wrong, sorry. Python app.py. There you go. Look, it's working exactly the same as we had before, but now it's more professional. We're doing it in a better, more professional way. So that's the first step. That's file splitting. We got a file for generation. We got a file for data. That's fine. Now, naming conventions. Now, what's up with naming conventions? All right. Now, right now, we have a terrible way of naming things. That's the truth, guys. That's the truth. Look at this. Who index? What's that? I think we need a cool underscore here. What do you guys think? Who excuse? Nah, we need this, a cool underscore. So that's called naming conventions. All right. A naming convention is basically a way. Oh, what happened? Okay, yeah, I'm there. A naming convention is a way you write your code. It's like a style. All right. For Python, we use a snake case and camel case. You're right, Mr. Jorge. Yes, camel case is used in JavaScript. A snake case is what we use for Python, right? For Python, we also use Pascal case and a screaming case. We use those three, right? But the most used one is a snake case. Now, if you take a look at Python code, you will see that it's written in this way. If you want to create a new variable, it's always a snake case. If you want to create a function, it's always a snake case. So instead of having everything connected, we just do like this. What index? What excuse, right? We separate the words with an underscore. We do this. This is the way Python developers write their code. So if you do this again, you'll be showing that you know what you're doing, that you know your stuff. Because not everyone is concerned about naming conventions, right? So when I do all of this, my code is now easier to read. Who index, who excuse, right? That's fine. Of course, for Python, we got classes, and that way we write them with Pascal case, or we got constants, like environment constants. We use a screaming case. Now, naming conventions is a very interesting stuff. It's something that you have to do every single day in your coding job, because that's the way you write your actual code, right? You have to follow naming conventions. Now here, we see explanation of what's naming conventions and what are the most common ones. As Jorge said, we got camel case, we got kebab case, we got a lot of them. All right. Now the important one here is snake case, and we just did that. Now, last but not least is modern Python. All right. So what's modern Python? Basically, we want to write our code in a more legible and a more professional way. Why? Because right now it looks like a big sausage. It looks like a lot of stuff thrown there and that's it. But let's make it better. All right? Let's try to make it a more understandable set of code. All right. So that's why we use functions. So functions are little blocks of code that execute something. All right? And they are reusable. So the way you create a function in Python is that you have to put def at the beginning. That means definition. All right. So if we see our logic, we got we got like two steps. The first step is reading the excuses.json file, and the second step is building the excuse. All right. So let's do that. Let's create two functions for those scenarios. The first one, let's call it read excuses file, just like this. All right, so this function, their only concern will be reading the file and then returning that. Oh, in fact, let's do it like this so it's more legible. Excuses. Let me grab this. Perfect. All right, so that's my definition. So I don't have to write this anymore here, so I can delete it. And then let's create another function. Let's call it build excuse. And for this function, we will receive a parameter. Now, functions, of course, they execute a block of code, but sometimes they need inputs. They need data, right? They need information to work with. So here we'll call excuse data. That's the name of the parameter. And then we'll have some information, right? So what is going to happen here? We need to have the who, the what, and the when, all right? So first of all, we are doing the exact same thing, except that it's not longer excuses, it's now excuse data, all right? That's fine. Then we want to, here, when I do who, what I'm doing is that I'm basically grabbing this information right here, as we had it before, grabbing this information right here. We're doing the same for what and when. So now we want the actual value, all right? We want the actual value, like we were doing here, that we can generate an index and then we grab the value, all right? So we're not going to do rand int anymore because this is an awful, well, not an awful way, but I think there are better and more understandable ways to have a random selection. And the way we can do that is with the choice utility. So what's that? What's that? Let's do that. So let's have the who excuse equals to random the choice. Look at this, choice, and then who. And let's do the exact same thing for what and when. Beautiful. So look at this, guys. We got 6 lines of code that can be now removed because we don't need to generate an index anymore. What random choice is doing is that it's basically getting a random value out of an array. We don't have to do like the from 0 till the whatever index. No, random.choice, it will get a choice out of an array. Simpler, right? Way easier, way more understandable, of course. So build excuse. Now, first we define the data here. Then we get a random choice for the who, the what, and the when. The last thing is to actually build the string. So this is a good way to do it. This is called the string concatenation, but we can do it in a better way, in a more modern way called F strings. So I can do this syntax right here where everything is inside these double quotes. And inside the brackets, I will put the variables in the exact same order. So I do who, I do what here, second, and then I do when, third. All right. So instead of like writing the variable plus a space with string, we can do that in a single line just like this. We are setting the space here. If I do a comma here, we'll have a comma. If I want to have like a hyphen here, we will have a hyphen, right? It's whatever we want to separate these variables with. All right. So this is what we have right now. This is way better. This looks more professional. This looks clean. All right. And we did what we promised. We got two functions, one for reading the file and the other one for building the excuse. Now, what is left is just to call those functions. Now, right now, we just created them, but we haven't used them. So we are going to use them right here. So we're going to trigger this function. And the way I trigger it is that I put this double parenthesis like this. That means that this function will start, will do this stuff right here, and then their value will be returned. That means that when I run this function right here, I will get this information. I will get this dictionary, this JSON right here. So that JSON right there is going to be stored in this data variable. All right. Oh, wait, I forgot to return here. Excuse. That's fine. And then it is stored in data. And then I want to do this. Then I want to, oh, hold on. Oh, not really. I don't think I really need to do this. Just return it. And let's remove this line. That's fine. All right. So I run this. That means that we're getting the data from the file. Then I'm storing the data inside the excuse variable. So I put this function here, and then I send data. So I want to show you this, guys, because this can be a little bit tricky, a little bit confusing. Is that I'm calling the function called build excuse, and I'm sending this argument called data. That means that excuse data will have the same value as data. All right, so it will be exactly the same stuff. That's why I can do this. I can grab that information. And at the end of the day, at the end of our code, I will do excuse, print excuse. That means that first I will read from the file, then I will generate the excuse, and last I will print it. So let's run our code, clear, and Python app.py. There you go, guys. It's there. Now, it's the same output as we were having before, right? But now our code looks like it was written by a senior, well, mid-level, but it was written by someone that knows their stuff. So we passed from generated indexes, concatenating strings, having everything in the same file, to a more clear and concise code, all right? Any questions, guys? All right, nice. So that's up for our good practices. We got the file splitting done, we got the naming convention done, and we got the modern Python done, right? So now our code looks more professional. Last but not least, it's a debugging. So I will go a little bit quick with this one because I see that we're running out of time. But basically the debugger, oh wait, sorry, I didn't meant to do that. Yeah, so the debugger is basically your best friend. The debugger, it's a tool that you will use to run your code step by step. That's it. And it's very simple to use. VS Code allows us to use their debugger. That is what we have right here, like this small bug with the arrow icon. And then the steps to use the debugger are really simple. First, you need to put the breaking point. Basically, the breaking point is where you want the debugger to start analyzing your code. We want to start from the beginning. So I'm putting it right there at the beginning of the file. And that's it. I run and debug. It will then ask me on what engine do I want to use, but don't overcomplicate with this one. Just do Python file, and that's it. So look how cool is this? Because I know that some of you are kind of lost and are saying like, oh, I didn't understand the last part. That's totally fine. Don't worry, because the debugger will help you understand better. Why? So look at this. This means that our code will be executed line by line. All right. So this is that we are in the first line. So we got a couple of instructions here that we can trigger. So if I do this down arrow step into, that means that it will jump to the next line. All right. So look at this. Now here on the left, you will see how things change. Now it says that as a local variable, I have random. And that's true because now I can call it in some places of my code, as you can see here. All right. So that's the import of random. Now it will do the same for JSON. Now, if we take a look here on the left, now we got JSON and random. Beautiful, huh? Now we get here, it will define the function. It just did. So now we see that we got something called function variables. And if I open it, you see that we got here our function, read excuses file, right? It just created it. As you have seen, it hasn't run anything. It just created it. Now build SKUs. This is how the code actually runs, all right? So build SKUs, it will do the same stuff. It will just create the function as we can see here. Let me close this so we can have more space. All right, perfect. And let's, yeah. So we got build exercise, read excuses file, JSON and random. Now all of that is declared in our code. Now we are getting into business because I just declare the functions. I haven't triggered them yet, but now I'm doing so. So I will trigger the first function that's called read excuses file. So I will get into it. So when I do that, look at this magic. It will go back there. It will go up there and it will trigger this open logic. So this open logic basically is going to read from the file and then it will get this. It will get the info of the file. Of course, it's a lot of gibberish, but don't worry about it because when I click on the step into, you will see that now excuses will have the value that we got in our JSON. Look at this beauty. Who, what, when. Do you see this, guys? We just read from the JSON file. And because that's everything that this function does, it will just return. It will return that information. So we can see now that, oh, it hasn't finished. Yeah, perfect. So we can see that when I move from here, it will say that data now is this stuff. It's whatever we read from the JSON, right? So now I'm sending this stuff into build excuses. Let's get into there. So it will get into the function, and then you'll see that excuse data, just as I said, it will have the same value as whatever we read from the JSON. And we can see that here. So now this is very straightforward. Who variable will have the value of who, as we can see here. Look at this. Who now has the value of who. Now it's stored in our function. And I will do the same for what, and I will do the same for when. Right? So I will just move and move. That's nice. And then we can see that we got what, when, and who. And every single variable has their value, right? So that's what we had at the beginning, right? But now it's in a more professional way. Now I do a step into, and now who excuse is going to be one random choice. So the random choice that it took is the dog for who. Now let's see what happens for what. It will trigger the random choice. Crushed, as we can see here, crushed is the random choice that it took automatically. And then the when excuse will be, when excuse will be right in time. All right, so the function just grab the values, sorry, the function just defined some values out of the JSON, grabbed random values for every single one, and then it will return the string, like the concatenation of all of that. So we will see that the return data, look, where is it? Module JSON. No, I just have to do this. So you will see that excuse variable will have our final thing. Look, it has the final string, the one that we actually print. So I remember that Mr. Damien, that is not here anymore, said that it's magic. As you can see here, it's not magic, guys. Everything has a reasoning programming, as you can see here with the debugger. And now our excuse variable is built, right? And when that's done, look, it will just print this stuff here. It finished. How cool is that, guys? Now, this is a very simple example, but in the future, when you're in your job, you will see that many times you will need to really see how things develop step by step. And the way you do that is with the debugger. So I hope this was educational for you, and then you get my advice on using the debugger. That is important. All right. So that's the last part of our workshop. Now we got some recap and final words. First, Python is a solid and popular programming language with a wide range of job opportunities. So learn it. It's very good advice, guys, and you'll be doing great in your job opportunities if you do so. Sometimes most of the work lays in understanding the solution rather than coding itself. There is a very funny graph that says like coding work is almost 80% planning. No, it's like 60% planning, 30% debugging, and 10% coding. It's like that, guys. So knowing what you're going to do, having a strategy, and knowing your stuff, it's valuable when you are coding whatever you want, because that will give you the right tools. Next, debugging code, regardless of its size or complexity, is an amazing way to understand the step-by-step of your solutions. Now, I can't advise this enough, but if you're learning how to code, use the debugger all the time, because there is no best way to really get what's going on, but if you follow the logic step by step. All right. Last but not least, good practices in today's tech industry are a must. This improves legibility and collaboration. Now, guys, good practices are everything. They will speak for you, right? It's not the amount of experience. It's how good you are with your practices and your standards when you're coding, right? So this is our final slide. Coding is not an easy task. I know that some of you, yeah, ChatGPT. So coding is not an easy task. I know that many of you maybe are like, what was that? I didn't get anything. But that's totally fine. But if you feel motivated and learning how to code, guys, join us at 4Geeks. As I said, I had an amazing opportunity teaching a cohort, and I can really speak about the quality of the learning here. And who knows, I can be your teacher in the cohort. So if you like what you see, if you like how I explain, we can see each other for sure. So that's it, guys. Thank you for your time and your attention. Woohoo.
I had a quick question about the 4Geeks program. Is that like a monthly payment type of course, or what does the fees look like for it?
Oh, I don't know. I don't know if you want me to answer, Janet, but I think you are the designed one for answering this question.
Yes.
But it's okay. I mean, I can answer if you want.